All right, so you'll have, as I said, you'll have 4 free response questions at the beginning. They're going to be on the back side of your form, and they'll be sort of separate from the rest of the test. I would recommend that you just do those first, because they're worth actually 8 questions, because each one is going to be worth 2 questions each. Now, if you get them all right, or you get the right answer and the work is shown correctly, then you'll get, all the credit for that. So that's about 6 points per question, a little more than 7 points per question. But I'm going to tell you what they are, so everybody should get those right. The numbers aren't going to be tricky. They're going to be like I'm going to show you. If you know how to do it, you'll know how to do it, and you'll get them just right. But I will want to see your work. So make sure you show that. If you show it clearly, then I'm more inclined to give you partial credit if you get the answer wrong. You'll be able to get full credit, half credit, or no credit at all, but nothing in between. Okay? So if you get the wrong answer, but you show the work correctly, that'll be half credit. And as I said, there will be 4 questions. Most of them will be centered around this configuration of charges. I'll give you 2 charges, and I'll tell you there's a point up here, say a point A. That's not a charge, that's just a point in space. And I'll ask you, what is the electric field, what is the force, and what is the potential at that point? The electric field and the potential are just related to these 2 charges. But the force, I'll have to tell you a third charge to put there to figure out what is the force on that. And you probably know where I'm going with this, that if you know the electric field, it's easy to find the force, right? Now, one of the questions will ask, the very first question, which is going to ask the electric field, will ask for both the direction and the magnitude. And I'll be looking for both of those, okay, for that question. But it's still going to just count as 2. Let me just make up one here and we'll work through it. And then that's going to be what you'll have on your test. No tricks, nothing, going to be exactly that. Don't look at me like that. Like, that's what it's going to be. No trickery, okay? Y'all trust me? No, you don't trust me. Yeah. No trickery. So I don't know. Let's just. I'm not going to make up nice round numbers. I'm just going to give you. Let's just say this is 2 coulombs. This is minus 3 coulombs. And let's say this is 3 meters here and 2 meters here. Though I will tell you that on the test, I made the numbers work out easier than the way these numbers will work out. Okay. First thing I want to do is I want to figure out what is this distance. Look, that's a right triangle right there. And so I can figure out that distance. It is 2 meters on this side, 3 meters on this side. And so it's the square root of 4 plus 9. Square root of 13. It's 3.6 meters. Just a little note, I will want you to keep proper sig figs, but just keep 2 sig figs. The problem has 2 sig figs all the way throughout, so just make sure you give your answer in 2 sig figs. In general, that's true. It's not always true, but in general, you look at the numbers that are in your problem, and you should have the same number as sig figs in general. That's not always true, as you know, because we've done sig figs before. So anyway, that's my distance. If I want to know the electric field at that point, I will draw my coordinate system right there. I have 2 vectors. One is going to be up and in that direction, and then the other will be in that direction. The electric field, this is probably going to be the hardest of the 4 problems, because you're going to have to resolve the vector into its components. By the way, if I wasn't doing this thing with the free response, you'd still have this question. It would just count, half what it usually does, and I wouldn't tell you what it was. So it's all good. There's my vectors. I need to know what this angle is, but recognize that that is the same as that angle. Now here I've given you a 2, 3, 3.6 triangle, but you can probably guess what triangle I'm going to give you on the test. Which one is it going to be? The 3, 4, 5, because it's a nice easy triangle. You probably even know the angles already, right? 53 and 37 degrees, so you can bypass this whole step of finding the angle if you just know that triangle really well. But if I want to know this angle, that angle is theta. Theta is the inverse tan of 3 over 2. That's just a SOHCAHTOA. And the inverse tan of 1.5 is 56 degrees. So this angle is 56 degrees. Now I also need to figure out what is the magnitude. I'm going to call this vector E1 and this vector E2. So I find E1 is KQ over R squared. That's equal to 9 times 10 to the ninth. Q for E1 is 2 coulombs divided by 3.6 squared. I have to use my calculator for that, though in many of these problems on these first 4 questions, you probably won't even need your calculator. I try to make them so they work quickly. And that's 1.4 times 10 to the ninth. What I get? It's in newtons per coulomb. E2, in a similar way, is 9 times 10 to the ninth. Q was 3 coulombs. Notice I leave the negative off. And the distance is 2 meters. That's squared. And I get 6.8 times 10 to the ninth newtons per coulomb. Okay, now that I have that, I have to find the component vectors. I have to find this and this. This one is going to be, what was that, E1 cosine of 56. E1 cosine is 56, that's 1.4 e to the ninth times 56. That's 78. Or excuse me, 7.8 times 10 to the 8th. And then E1 sine of 56, that's going to be this component, the y component of that, is going to be 1.4 to the ninth. That's 56 sine. You get 1.2 times 10 to the ninth. Did I do that first one right? Let me double check that. I think I might have put in the wrong number. $7.8. No, that's right. That's right. Okay, so those are my x and y components. So now I have 3 vectors that I'm dealing with. I have this one, and this one. I need to add up those 2 x vectors, and so it's going to be, where's my other vector? E2. In the end, my system's going to look like this. I have a vector here and a vector here. This one right here is going to be 7.8 times 10 to the 8th minus 6.8 times 10 to the 9th. Which is 6.0 times 10 to the 9th. It's negative, but I drew the vector in the negative direction. And then the y component is, I've already found that, it's the 1.2 times 10 to the 9th. All right, you with me so far, people? This isn't new, but we can take a little pause if you want. I've drawn all these little vector diagrams and stuff. You don't have to do that on the test, but I will be looking for calculating E1 and E2. All right, I at least want, if you're confident that the number is right, I'll be okay. Just, no, I want to see the work. I want to see the work. But you don't have to draw these features. And then I want to see your x and y components. You don't need to show the trig if you just know the triangle. Like I said, it's going to be a 3, 4, 5. So if you just know that triangle, that's fine. Yeah. All right. Questions so far?
So the goal is to get the electric field, the force, and the voltage.
Yeah, this is just the first one. And the first problem is going to be the hardest because it sort of has the most steps. The second, third, and fourth are much easier, huh?
But you mean by just the first one?
Like there'll be 4 problems, and the first problem is to find the electric field.
Oh.
So this is just the first problem, and it's the most difficult. But it'll be the very first problem. You'll make sure you practice it, okay? All right, we did one in class. If you look back at the old test, you can see some examples too. We're not done with this one anyway, by the way. William?
Where did 1.2 go?
The 1.2? The 1.2 is the y component of E1. It's right here.
So there are two vectors that need to be solved, or just three?
Two vectors that need, I don't understand. What do you mean?
What's required in the answer? Do I have to solve for 2 or 3?
No, we're not done. I haven't given you the answer yet. No, that's not the answer. So what we have now is we have the x and y component, and we want to know that vector, and we want to know the angle from the positive x-axis. If you give the angle from the negative x-axis in this case, I would not count that incorrect. That would still be okay, but you just need to make sure that you tell from which axis you measure it. So to find the magnitude of that vector, I say the square root of 1.2 times 10 to the 9th squared plus 6 times 10 to the 9th squared. That gives me the magnitude. It's 6.1 times 10 to the 9th? Is that right? Okay, yeah, I guess that makes sense. That's the magnitude, so that's one part of the answer. And then I would want to know this angle. So to find phi, that would be the inverse tan of 1.2 over 6. Hmm? No, it should be positive 9. Isn't that right? Yeah. Because we had that k value. So 1.2, that's what, 0.2, the inverse tan of 0.2? I get 11 degrees above the negative x, or from the positive x, and that would be what, 180 minus 11, 169 degrees. Okay? That would be the answer for the first question. I understand that's a more difficult question than the 3 that follow, but I'm expecting everybody to get all 4 right. Right? Y'all will get this right, won't you? Yes? Don't give me that frown.
No, I'm just so like, which letter is that? Is that the E, the F, or the B?
That's E. So I know they all sort of look the same, and they really, the E and the F, they are a lot the same. Really, the only difference in finding the electric field and the force vector is this step right here, that when you're doing F, you do K cubed Q over R squared. But don't freak out, because once I get E, then I practically have F. Like F is just going to be like nothing at all, right? Because F is equal to Q times E. And so I just multiply E times Q. And so once you get E, then F comes really easily. And by the way, if you mess up on the E, but then you do the F right, you'll get full credit. Even though you don't have the right answer, if you do it right for the second problem, then you'll get full credit for that problem. You understand? Like, I'm not going to let it carry, like, one mistake in the first problem carry through to the others. That's the really nice thing about doing free response, is that if you just make one little tiny thing, then I can account for it.
So we're going to be using the same values for finding.
Yeah, you just have one figure with all the same charges.
So whenever one of the vectors is in between a right angle, you take the cosine and sine of theta times one, right?
You have to find the x and the y components right here. If I had this vector, I had to find the x and the y components. So I get these 3 vectors, and then these 2 in the x direction, I have to resolve into one vector. So I wind up with just 1 in the x direction and 1 in the y direction. That's really what I'm doing.
Since there's no other charge in the x direction, and only a charge in the negative x direction.
Well, this vector was bigger than this vector, so that's why that vector is to the left instead of to the right.
So why were they subtracted from one another?
Because I did this minus this, 7.8 minus 6.8, and then I get this 6 times 10 to the 9th. Actually, it was negative 6 times 10 to the 9th. That's a negative number. But the result is that this vector is pointing to the left.
And that basically makes up a triangle.
Mm-hmm. Yeah, it's a triangle. It's a right triangle. Courtney.
Will you take off if we don't put like the right?
Yeah, like if it's you, I'm gonna count off the entire credit. But if it's anybody else, they're gonna get full credit. No. Yeah.
What are you saying? Full, half, or not?
No. I mean, if y'all don't put your units, for goodness sake, just put your units.
What if you put the wrong units? Like, what if you do everything?
You can't take half off
but
of
you
that.
put the wrong
That's easy.
It's a Newton per Coulomb. That's just the unit. All right.
Point system.
All right. No, I won't count off for just units. But just put your unit. It's a good practice to always write your units.
So E1 and E2 are both force vectors.
Now, E1 and E2 are electric field vectors.
So they're vectors, and what you want to do is you want to put them into their respective X and Y components, which is why you did your cosine and sine.
Right.
And then you add them all together to get your resultant vector.
Right. So let's step through again. First, I figure out what vectors do I have, and I do that thing where I imagine I have a positive charge here. What's the force that positive charge feels? It's repelled from this one and attracted to this one. Then I come over and I draw those vectors, and I figure out the angle here using my SOHCAHTOA. That you're going to know it because it's a 3, 4, 5, and you just know those angles, 37 and 53. And then I resolve that vector by the cosine and the sine, and I get the magnitudes for these vectors. Now this vector goes away, and I'm just left with 1, 2, 3 vectors right here. And then I add these two up. I do the vector sum, which leaves me just with this vector, and now I'm almost home. I have this vector and that vector, the x and y components of the resultant vector, which is what I want to know. That's my end result, is that I know the length of this vector and the direction of that vector. And you can express this angle either from this axis or this axis. So I think in the problem I asked for it from the positive x-axis. So whatever I say, you just follow that.
Now, how do you find the direction again?
Oh, I do SOHCAHTOA. So the tan of theta is opposite over adjacent, right? And I do the inverse tan of opposite over adjacent sides.
I was just thinking about completely electric.
I try to make the math as simple as possible. Like, I think you really probably can go through and work all 4 problems with maybe using your calculator once. Okay? And you're going to say, gosh, this is really easy. And then you're going to high-five me on the way out of class. You're going to be all excited about it. You're like, let's make the next test all 3 response. You wait. It's going to be you. Okay? You too. All of you. It's going to be all of you. Okay? All right. Well, now the rest of it's easy. Because in the second problem, F is equal to Q times E. What I would ask you is I would say, okay, now let's say that I put a 4 Coulomb charge right here. What force will it feel? But if I know the electric field, then it's super easy. I just say 4 coulombs times the electric field, which is 6.1 times 10 to the 9th newtons per coulomb. And since I got my units right, I can just do a quick check. It's like, ooh, that gives me a force. And then that's, 24 times 10 to the 9th newtons. Yeah, it's going to be that easy.
So, like, are you gonna, like, in number 2, are you gonna say, oh, so if you put a 4 Coulomb force where point A is, then find the force?
Can you repeat your question?
I'm just confused myself.
Okay, just repeat your words.
So, are you gonna tell us, like, in question 2, be like, okay, like, you just did all this work, and then are you gonna be like how you put the 4 coulomb? Are you gonna tell us to do that?
Oh yeah, I'll say, okay, now imagine that there's a 4 coulomb charge at point A. Or if there were a 4 coulomb charge at point A, what would the force on it be? Okay? I understand that numbers 1 and 2 are different in difficulty, but I figure, well, number 1 is difficult, and so we'll just have a gimme question with number 2. I know it's not a gimme. If you don't know how to do it, you're going to get it wrong, right? But
It's negative 4, so you just put in the negative 4.
I'm not going to ask you. Yeah, if it was negative, you would just change the direction. So this one is going to be 24 times 10 to the 9th at 11 degrees above the negative x. If it were a negative 4, it would be the same, 24 times 10 to the 9th at 11 degrees below the positive x. It would be exactly opposite. But I'm not, it would, like, the first one would be here, the other one would be here. But I don't ask you the direction. I just ask you the magnitude. Okay? Yeah, Justin.
Just curious, if you get an answer like 24 times 10 to the 9th, and you put 2.4 times 10 to the 10th, would
That's fine.
you take off points?
No, of course not. That's the same number. All right? Okay? Now, and even sig figs, honestly, don't fret too much about your sig. Just keep 2 sig figs. I'm not going to be grading for sig figs. I want everybody that has the right answer to have similar numbers. You know what I mean? Like, not somebody has 2.4 and then another person has 2.4359. Because then it just makes it difficult for me. Number 3, numbers 1 and 2 are kind of related. And number 3, I would ask you, what is the potential? You look at my figure up here at a -3 and a +2. And this distance was 3 meters. And this distance was 2 meters. So if I find the potential at this point, is the sum of the individual potentials, or V1 plus V2, and then that's going to equal to 9 times 10 to the 9th. Q is -3 coulombs divided by 2 meters plus 9 times 10 to the 9th times plus 2 coulombs divided by that distance. We found that distance up here, 3.6 meters. And that would be your answer. Easy, right? Like, that's easy? In fact, regardless of whether we did free response, you'd have to do these questions anyway. You would just have 4 options to pick from. So you're not really doing any different problems. You're really just doing fewer problems on the test. I'm just making some of them count more. And you get the option for a partial credit. William?
So you don't do the absolute value of the charges?
Nope. Remember, because for electric field and force, you do the absolute value because those are vector quantities, and the signs of the charges come into play when you're drawing the vectors. But for potential and potential energy, you include the signs because those are scalar quantities. And it's sort of like when we were dealing with work, that was a scalar quantity, but we still kept negatives because it was like, are you taking energy or giving energy? And it's a similar thing here. So the signs are important here. They don't denote direction, but they denote, are you giving away or taking energy from the charge? Okay? That's number 3. And then number 4 is going to be apart from that figure. It's going to be a separate problem. I'm going to tell you, what if you take a charge and I move it from one potential to another? Let's say that it's moving from that point to that point. And let's say that it moves, I don't know, from 2 volts to 6 volts. Then it moves from a position where the potential is 2 volts to a position where the potential is 6 volts. And I would tell you what the mass is. It's 2 kilograms. I mean, it's not. I'm just trying to make numbers that work. The charge is 3 coulombs, and I would want to know what is the speed of that particle when it reaches this new position. We've done problems like this before. We've done several. What I need to do, first of all, is find the potential difference. In this case, it's going to be the final minus the initial, so that's 4 volts. And I know here, oh, this isn't a very good example, actually. Because a 3 coulomb charge wouldn't move from 2 to 6 volts, right? A negative charge would, but a positive charge wouldn't. Let's just run with it anyway, it's okay. Y'all follow what I'm saying? Positive charges move from high to low potential. Negative charges move from low to high potential. All right. So I would just say Q times delta V is 1/2 mv squared. This is the work done by the electric field. So that's going to be 3 coulombs times 4 volts equals 1/2 of m, which is 2 kilograms, times v squared. It's 12 root 12. That's 3 point something. What is it? 3.5. Okay? The signs aren't that important because I'll just be looking for the speed of the object. So I'll have the potential set up correctly. So if it's a positive or negative charge, it's moving in the right direction. And it won't really matter for you to use the charge here. And you can use it, but since we're only looking for the magnitude of the speed, then the sign of the charge isn't important. That's it. That is 8 questions on your test. That's 1/3 of your test. And I just gave it to you. What?
That's not on the equation sheet.
Yeah, it's on the equation sheet, isn't it? Can I see it?
Because that's one of the problems I was doing. I couldn't find the velocity on the equation sheet.
Oh, no, there's no velocity on the equation sheet. That would, where is it, Kristen? Oh, here we go. It's sort of embedded in there. It takes a little work to figure it out. It says on the equation sheet that delta V equals delta PE over Q. So like it's written in code language. And delta PE we know is the same as work. That our work is equal to our change in potential energy. Are you giving me a look?
No.
Yes, you
It's
are.
like I'm making like that. This is like okay, what happened?
Okay, and so work is equal to Q delta V. But work changes our kinetic energy. So 1/2 mv squared equals Q delta V. So it's there, it's just written in code.
That's for the memorization.
No, y'all don't need to memorize. Y'all know kinetic energy, right?
Yeah.
You know kinetic energy. Okay.
I do know kinetic energy, but it's just hard to make that connection when it's involving charges and all.
I hear you, but I'm telling you, we've done examples. I'm telling you, this is on the test, so it is on there. Okay.
Yep.
So y'all need to know it, and don't write on your hand because I will look on your hand. I'm serious. Or just know it. 1/2 mv squared. 1/2 mv squared. Write it on your mirror in magic marker, and you'll know it by Monday. You'll have it down pat. All right. Instead of looking at your beautiful mugs, you'll be looking at kinetic energy. Seth?
About the 3.6, you are getting that from doing like the hypotenuse, right?
Yes. So the 3.6 I had gotten right here in the very beginning. Like I said, the first 3, that's what you're talking about for number 3? The first 3 will all be related to the same figure. And it's not going to be a complicated thing like that. It's just going to be a 3, 4, 5 triangle.
So you just have these 4 problems to do on the group on.
Right. And then you'll have 20 other questions. Or 19, I think. And then you only get one freebie.
So for the force question, the description is gonna say like, what if point A is replaced with a certain charge?
That's right. What if you imagine that you put a charge at point A, what would the force on that charge be?
And for voltage, it's gonna be asked, what is the voltage for point A?
What is the potential at point A? Yeah. Yeah, of course. Right here? Man, you're welcome. Look at me. I just gave you all the answers for a third of the test.
Or you're gonna change the numbers we give the actual.
I'm going to give you easier numbers. I'm just going to make it easier than this. Because the numbers, I make them to cancel things out. So that you're 9 to, like you'll see nanocoulombs. And so that gets rid of the 10 to the 9th and K. You'll follow what I'm saying? If you have a charge of nanocoulombs, just don't even bother writing the times 10 to the 9th and times 10 to the minus 9th. Just leave those off. Because you know that they cancel out. That's what I do. You follow what I'm saying? That if I have like, K times 3 nanocoulombs over, now let's make this. What's a good one? 9 nanocoulombs, and our distance is 3 meters squared. Look, that's an easy one because I just say 9 times 9 over 9. Boop, 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 boop. That's equal to 9. It'll be something like that. You only need to use your calculator. I'll use numbers that cancel out easily. So
K will always be 9 times 10 to the 9.
yeah, K is always 9 times 10 to the 9th. So what I've done here is this is 9 times 10 to the 9th. This is 9 times 10 to the minus 9. And listen, you'll have some calculation problems in the 20 multiple choice, but you won't see any two-dimensional stuff. I'm going to limit those because I know that this takes a significant amount of time. You will see some calculations, but they're going to be easier. The test really isn't that much different. Really, it's just that the test is shorter because you would have had these questions regardless. They just would have been multiple choice. But in this way, you get to show, you know, what you're thinking. Okay? That's good news for y'all. I know y'all are a little anxious because it's just different. But this is a great thing for you. A great, great thing. Yes.
So exam 1 in the back of the test should be pretty representative of what we're going to have.
And on the website. Have you seen the website? Yeah, I know we have a few people that are new.
With the answers on them?
Yeah, they have the answers. Give you everything. So if you go to the website, if you go to old exams, look, every exam I've ever given. Yeah, you didn't have me last semester. So there's exam 1 from spring 15, and then if you click on the video, it's just me working through that exam. Okay? So that's a good resource. Huh? You just go to the website. It's linked on Moodle. It's this website, and it's linked right on the top page of Moodle. And you just go down to old exams. And by the way, there's physics 1, the homework, which are in the back of the book, and there's some problems that are similar to the ones that we just worked in the homework. That's the problems in the back of the workbook at the end of each chapter. They're there, and then they similarly have solutions to all of them. And then if you want, you can just, these are the problems. Those are in the back of your workbook. And then there's screencasts. These are just the lecture from each class period. And our help sessions are here. So this recording will be there. Okay? Who else is new? Just you, right? Yeah. We have a few others in the class that are new too. All right? What else do y'all want to work on? Want to work on other stuff? Is that all y'all came for today? You have a question?
Questions from test 1 in the back of the book.
Okay. If y'all want to go, that's fine. Just come see me and I'll mark your name, okay? If you want to hang around, that's fine too. Which one?
11 and 12.
Which test is that? Is that
Exam 1, Physics 102, S
16?
11 and 12, 14 and 15.
Okay. 11 is similar to what we just did. 11 is a little bit simpler because I don't have to resolve the vectors. Did you have a specific question?
No, actually, I did 11, it was 12, the direction.
Okay. Do you know what these vectors are? Well, I can do it right quick. Actually, it's 9 times 1 divided by 3 squared. So that's 1 Newton per Coulomb. And then this is 9 times 2, 18 over 9. This is 2 newtons per coulomb, right? I did that right? Look, and then you're done almost. Did y'all see what I did there? I said 9 times 10 to the 9th times 1 times 10 to the minus 9th. That's 9. 9 times 1 divided by 3 squared. That's 9. So it just becomes 1. Easy, right? But look, I want to see your work though, so don't just do that. Make sure you show your work. Because if you get the right answer and no work, how many points do you think you're going to get? Okay? Show your work.
I got -1 for
That x component?
yeah.
When you're finding electric field, kq over r squared, absolute value bar is around q. So there's no negative. The way that I find the direction is I imagine a positive charge there, and I ask myself, what is the direction of the force? And it would be attracted to that -1. Now, to find the direction, I need to know this angle, theta. Theta is the inverse tan of 2 over 1. So that's 63 degrees below the positive x-axis. B. Okay?
You said all this is on the website.
Yeah, so if you go to the website, under old exams, that was spring what? 16. If you just go to the video, it's just me working through it. Like, it might put you to sleep if you're having a sleepy day, but you'll find the answers and how to work it. I go through just what I did. Emma, you have a question?
I just want to say that's how to set your test. Like, go through the videos.
She's
I
right.
went through all of the tests, like,
Mhm.
like spring of 2006.
Yeah.
You will pull one question from that.
No, I don't. No, I don't pull questions from those.
Promise you will.
Sometimes I pull questions from old exams, but
Concept.
almost all of my questions are brand new questions. They're different. I mean, they're on the same content. Don't roll your eyes at me. Almost all of the questions are new questions, but they're very.
There's like a couple concept questions though that are like similar.
Well, like one of the questions on this test was the first one, which had to do with elementary particles.
Oh, the cork thing? Yeah. I think that semester those students had that problem in an online quiz or something. We haven't talked about cork, but you could answer that question. You could answer it. If y'all are pre-med, you better be prepared for that because you're going to see stuff that you'll know how to answer, but it's just going to be, entrenched in different language that you might not be familiar with. In fact, if you want to do well on the MCAT, you need to know the content of physics and biochemistry and general chemistry, organic chemistry and biology. Or you need to know the content backwards and forwards, but you really need to know how to read things that are different from what you're used to reading. All right? MCAT's a killer test, isn't it? It's tough. Who's pre-med? This year? Anybody else? Bless you people. Why you people want to be doctors anyway? Too much business to be a doctor, goodness. No, it's good. You get to help people. It's a great thing. All right. What else, y'all? William?
Is there going to be a question that's the electrical potential where it involves like centimeters positions?
On those 4 free response, everything will be in SI unit. Well, no, it won't.
Because I encountered the question for the number 12 quiz and something else doing.
Well, if it's in centimeters, just convert it to meters. Move your decimal place over 2 places. And then that, like if it's 12 centimeters, that's 0.12 meters, right?
I get that, but it's over the desired choices answer, like over 100,000.
Y'all want to look at it? What is the question?
Is
Can I see your thing here? Your computer? Look, I'm not going to work it, but I'll show you how it sets up, okay? This is a fine question. So this is number 12. And really on this, you just have to draw your coordinate system. It says Q1 is at x equals 3. Boom, boom, boom. So I have a charge there. It's 25 nanocoulombs. And Q2 is at y equal 5. 1, 2, 3, 4, 5. And so this one is 15 nanocoulombs. This distance is 5 centimeters or 0.05 meters. And this distance is 3 centimeters or 0.03 meters. And I want to know what is the electric potential at 3,5 at this point. So it's just V is equal to KQ over R plus KQ over R. Okay, we can look at that. But in this, you know your Q values. They're 15 and 25 nanocoulombs. Notice the nano cancels out the 10 to the 9th on K. And you know your R values. It's 0.03 meters for this one. And, excuse me, 0.05 meters for this one and 0.03 meters for that charge. And you add up those potentials. These are both positive charges, so it's just a sum of the potentials. Okay? Any other questions about the quiz? Have y'all looked at that yet? It's due on Monday, so we'll have some time if you want to drop by if you have questions. As usual with the quiz, so if you come see me, I'd love for you to come see me and I'll look at what you have. But you have to come to me with work. I'm not going to work through them with you, okay?
Is the reading assignment worth points?
It's worth a little bit. It's not worth that much. In the end, the reading assignment is worth 5 points of extra credit. And honestly, 5 points isn't that much in the class, but if you're the 3 or 4 people that it bumps up to the next letter grade, then it's important to those people. But it probably really only impacts 3 or 4 people. But if you do the reading assignment, some people are big reading learners, that they learn well by reading. I'm one. I like to read, and I learn from that. And sometimes it's useful to get a different perspective, like a different way from how I might explain it. The book will explain it differently. And if that's you, then by all means, I encourage you to do that. And I think it will help you in the class. Ready? Is that all, people? All right. I'll be around. Make sure I get your name before.